Hi. A sample space contains all possible outcomes of an experiment in which we are interested. If we approach a random person in Delft for a survey, then the sample space consists of all people in the city of Delft. Now, mathematically, a random variable is a function from the sample space to the real numbers. If this random variable only takes on integer values, then we call this variable a discrete random variable. For example, if we ask the random person, we approach in Delft how many times they traveled by plane in the past 6 months, then that is a discrete variable. Other examples of discrete variables could be the number of children this person has, or the last digit of their phone number. Now, a continuous variable is one where the variable can take on an entire interval of real numbers, or even the entire real line. If we return to a random person in Delft, then this person's height in meters is an example of a continuous random variable. Other examples are the time in hours that this person spent in traffic this morning, or the amount of fruit they eat per month in kilograms. Let's examine one more example, and this time our experiment involves throwing two fair dice, let's say a red one and a green one. The sample space in this case comprises all pairs of integers between 1 and 6. What are some possible random variables for this sample space? Well, we could look at the sum of both values, the maximum, or even the number of sixes that we throw. These are clearly all examples of discrete random variables. Now let's say that the variable we are interested in is the number of sixes we throw with two fair dice. This means that our variable x can only take on three values, 0, 1 or 2. Now usually we denote a random variable with a capital letter. In this example we will use the capital letter x. The function px will assign to each value k the probability that x takes on the value k. So for example, px of 2 is in this case the probability that we end up with two sixes after we roll two dice. The function px is also called the probability mass function of x. Now a random variable can take on three different values, but these values do not occur with equal probability. Let's try to determine the probability that x is equal to 2. Now just think, this can only happen if both dice land on a 6. Now since each die can fall on 6 different values, we have 36 possible outcomes in total. Because all outcomes occur with the same probability, for the two dice, we find that px of 2 is equal to 1 in 36. To determine the probability that x is equal to 1, we have to be a bit more careful, because it is the case that either the red die or the green die can land on a 6. If the red die lands on a 6, then the green one can take on 5 more values. Now the same is true the other way around. So this means that we have 10 outcomes where we end up with 1 6 out of a total of 36. So therefore the probability that x is equal to 1 is 10 over 36. Finally, the probability that neither die ends up on a 6 is 25 out of 36. Since in this case, either die can land on 5 different values, each value from 1 to 5. So this means that we end up with 25 possible outcomes out of a total of 36 possibilities. Okay, let's return to the example where we were investigating the height of people in Delft. Remember, this was a continuous variable. In order to get an idea about the distribution of people's height in the city of Delft, we could look at a sample of 100 people, and we could present the data that we find in a histogram. Now, a histogram is a type of graph that shows the frequency of data within certain ranges. Each bar represents how many times a certain range of data occurs. It helps you to see patterns and distributions in your data very quickly and easily. Now, some important remarks need to be made here. What you see here is not the height distribution of the entire population of Delft, only a sample of 100 people. It would be next to impossible to measure every inhabitant of Delft. Also, when we are working with a variable like height, we are usually not interested in the probability that someone is exactly 1.8 meters tall. And we typically would be looking at questions like, what is the probability that someone is between 1.8 meters and 2 meters tall? When working with continuous variables, we are more interested in intervals of outcomes. This is why we model the distribution of outcomes of a continuous variable with a probability density function. That's a continuous function like the orange one that you see behind me on the screen. A probability density function works like this. If you want to know what the probability is that a variable x attains a value between a and b, then the area under the graph of the probability density function between a and b is exactly the value of that probability. Okay, this was a short introduction to random variables. I hope you enjoyed this video, I hope you learned something, and I'll see you in class.